Okay, the next the next thing we're going to look at is we're going to look at a couple different angle relationships that's going to help us solve problems, kind of like the second set of ones that we were looking at on the last set of notes. The first kind of relationship we're going to look at is right here, vertical angles. Vertical angles, if we're filling this stuff in, are ones that are right across from each other when two lines intersect. So, like, for example, something I like to do sometimes that has always helped me remember them is I can kind of outline the ones that are vertical with these, and they share that bottom point, which in an angle is called vertex. And you can do that with two sets of them right here. That's kind of an ugly picture. But something that's nice about vertical angles, which makes solving problems with them a little easier than some of the other ones, is that they're congruent to each other, which means they're equal. So, like, I can say that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And what that means when I'm talking about congruency, we're talking about the actual thing. So, like, angle 1 is the exact same angle as angle 3. But as we're solving problems, we're not really talking about the things. We're talking about the numbers. So I can say the measure, the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. And we'll talk about why that's important and how that actually helps us in a minute. Okay, next thing down here, adjacent angles. Now, you probably know the word adjacent from other places. Adjacent means next to, and I'm actually, the second line down here is what I want to put there. There are two angles that are next to each other. The little bit fancier term for it is what we're going to put up here. Adjacent angles are two angles that share a common vertex. Remember that word. And they also share a common side. So, like in this set right here, the side that they share is this, the vertex being B. So the reason that helps us, what we'll see in some of the problems we do, is I can say, for example, that the measure of angle 5, right there, plus the measure of angle 6 is equal to that whole angle, angle ABC. And again, kind of like the vertical angles, we'll see how that helps us in problems. Hopefully complementary angles is something that's familiar to you. All complementary means is that when I take the angles and add them up, their measure is 90 degrees. They don't necessarily have to be next to each other like this, but they certainly can be. And the way that helps me with problems, measure of angle 7 plus the measure of angle 8 equals 90 degrees. And kind of similarly, right below it, I got supplementary angles. These are kind of words that you need to know. That's some vocab that's going to be very helpful to you as we move through this stuff. Instead of being equal to 90 degrees, I'm still talking about their sum, but their sum is 180 degrees now. So I can say that those two angles put together equals 180 degrees. Now down here, we're going to classify these angles. We classified before using words like obtuse and acute and stuff like that, but now we're going to get a little bit more specific in talking about pairs of angles. So it says classify each pair of angles using all names that apply. What that means is, like in number 1, using the definitions above, that meets a couple of different types of angles. One of them that you should be able to see right away is that they're complementary, because it looks exactly like that picture up top. But something else that you want to say about them, they're also adjacent to each other. because they share that common side, they share the common vertex, so I can say that as well. If I look next door at number 2, the only thing I can say about them is that they're adjacent, because I don't really know anything about their measures. I don't know what they add up to. I just know that they're right next to each other. Now, I want to point out something I said up top about complementary angles and supplementary. All supplementary and complementary means is that they add up to these different numbers. Supplementary adds up to this, complementary adds up to 90. It doesn't necessarily mean that they're adjacent. So if I'm looking at one like number 5, those angles aren't even anywhere near each other. But if you notice, 116 and 64, if I put those together, they equal 180. So I can still say that they're supplementary angles. But that's all I can say about them. I can't say anything about any of those other relationships. So now take a second, 2, 3, 4, 6, pause the video, and then we'll move on. Okay, actually pause the video one more time because I want you to use what we did on the last page to do this top part too, 7 through 12. I think you should be able to do that. And then once you come back, we'll look at some other ones. Okay. Now we're going to use those relationships that we looked at on the previous page to do some math and find different angle relationships based on pictures that they give us. So like, for example, if I'm looking at number 13, something that might be helpful to you is identify right off the bat what kind of angles you have. So the two angles that they're having me talk about are these guys right here. Well, using those other relationships, I know that they're vertical angles. I know that vertical angles are congruent. So if this right here is 107, this one's pretty easy. I know the one right across from it is 107 as well. So not much math really involved. Let's actually go next door. I don't have it circled, but at 14, again, let's think about the different relationships I know about these two angles to help me. I know that they're adjacent, and I know that they're complementary. And how that helps me is because I know when I put them together, they equal 90 degrees. So what that looks like is, well, x plus 71 equals 90, because x just represents some angle measure. And now solve that problem. I'll subtract 71 on both sides, and x is going to be 19 degrees. Now I want to go down here. You guys are going to try a bunch on your own. But I want to do one of these a little bit more complicated ones. Now, you kind of have to work your way around this picture. The thing that I see right off the bat, I'm going to almost ignore this stuff down here. Don't cross this out, or if you're crossing it out, make sure it's in pencil so you can erase it. I'm going to ignore that stuff down here, because looking right here, x and 127 I can see are supplementary to each other. They make a straight line. So that's the first problem I'm going to solve. I'm going to say, okay, x plus 127 equals 180. And now I'm going to solve that. I'll subtract 127 on both sides. X equals 53 degrees. So now I'm going to put that in there. So that's one thing I've got. Something that you should see now is, remember those, honestly, these should be some of your favorite angles, your vertical angles. These two right here are vertical. Well, I know x, we just said that that was 53. So if that's the case, I know y. So y is also 53, because vertical angles are congruent. And then the last piece, which is probably maybe the hardest one to see, is what's going on right here. If I know I got this line right here, I know over here that this is 90 degrees. if I know that's 90 degrees, then I know this is 90 degrees, and 53 of that 90 degrees is taken up by y. So what that kind of looks like then, I can set up a little problem that says, okay, z plus 53 equals 90, and now I can solve for z, making z 37. That one's pretty tricky. But I want you to kind of use that logic that I just walked you through. And if you have to, rewind the video and go back and look at it to solve the rest of the problems on this page. 21 through 23 are exactly the same as all of those. You kind of just have to draw the picture. And I would, for all of those, I would draw a picture to make it a little bit easier.